Welcome to our live session. I'm Matt Shell, aka Matt Mirafish. I will be doing a session today on the profiler. So the profiler is sort of the main diagnostic tool that we have in Unity for analyzing performance. And so we're going to take a look at that. We're going to use the Unity Labs scene, which is a project, which is a fairly complex, graphically intensive project, and we're going to be looking at that through the profiler. I'll give you a couple little profiling tips. It's not really a session about optimization. There's so many different directions we could go with optimization that I'm trying to keep it just more focused on the diagnostic side with the profiler and hoping to sort of teach you to fish so that you can go and figure out your own optimization stuff yourself. If there's a big demand for an optimization session, maybe we can do one down the road. But today, this is going to be a little bit more beginner focused. The profiler previously was a feature only available in the Pro edition of Unity. And now that it has been added to the personal edition and many more users have access to it, I thought it would be a good idea to give you guys a kind of a guide for how to profile your projects and how to improve performance by doing that. And so let's take a look at what we've got here. So you should now be seeing the Unity editor. I have the Unity Labs project open. You can follow along with this with any project as long as it has some things to be rendered and a couple of scripts maybe. But we're not going to be creating anything step by step. So you don't have to worry necessarily about following along stepwise. So the first thing we're going to do is pull up the profiler, which is accessible from Window, Profiler. You can press Control-7 on PC or Command-7 on Mac to access that. And I'm just going to open that up. Now, notice it pops up in its own floating window. Now, traditionally, if you have a two-monitor setup, this is a great use for two monitors because the profiler does kind of like to take up the whole screen. There's a lot of information that has to be displayed. You can dock it in a pane in the Unity UI. And maybe we'll do that temporarily, but as I go through it, we're probably going to want to make it full screen. So I'll be moving it back and forth, but normally I would use it on a second monitor. So for the profiler to be working, it needs to be open. And what it will do is it will sample the past few hundred frames and then store them in the profiler so that you can scrub through and look at each frame and look at what was happening in that frame. So let's just give a quick demo of that. So what I'm going to do is I've got the profiler open, so it's going to record. You can see the record here is toggled. I'm going to play. And then let's just run around a little bit so we can get some data. As you can see, data is appearing in the profiler. And we'll just fill this up. So this is probably, I don't know, what do we got? 300 frames, so 5 seconds of data, right? And as we start to get more, it's going to start to drop the previous frames. So that's worth noting, right? So you want to kind of profile it in small chunks. You don't want to go for 5 minutes and then try to go back because it's not going to be there. It's flushing it out as it gets another few seconds. And so once we have this, now I'm going to pop it back out into a floating window and maximize it so we can see the whole thing. As you can see, it's nice to have some screen real estate for this. And so I can now drag my cursor through and look at what's happening in any given frame, right? So here, for example, we've got, it looks like a little sort of spike there. We could try to figure out what exactly was happening there. And so we've got these different areas, and you'll see you can actually scroll down. I think that Physics 2D is not open by default. Network Messages is, but if you want to edit what's here, so in this case, I have no 2D physics in this project, right? So I can click to close that area. I'm also not using networking, so I'm going to close those as well. And if you want to add those back, you can just choose Add Profiler and choose the area that you want to add. Now, so The areas that we're going to look at are going to be CPU usage, right? So calculations made each frame by the CPU. This is broken into separate areas, including scripts, physics, the garbage collector, GI, which is short for global illumination, vsync, others, and rendering, right? As we can see right now, rendering is taking up the vast majority of the CPU usage. And this is because this project really is more of a graphics demo than anything else. So there's not like any complex scripting really going on. There's not like a lot of enemy AI going on or anything like that, which might be computationally demanding. We've also got a rendering area here where we can see batches, set pass calls, which is the new sort of encompassing term for draw calls in Unity 5, triangles, and vertices, right? So this relates to rendering 3D graphics. We've also got memory. We can see the total allocated, texture memory, mesh memory, material count, object count, total memory allocated to the garbage collector, and GC allocation, garbage collector allocations. Anytime you see GC, it's garbage collector. And we'll talk a little bit about the garbage collector as we go through this session, but I'm not going to go super deep on it. We also have an audio area. We can see the number of playing sources in a frame, the number of audio voices. This is the number of objects playing with using audio source.play. Does not include things using play one shot. And then physics, the number of active rigid bodies, and then the number of contacts that those are making. And you'll notice as we click on any of these, we get we have our graphical timeline view, and then we get a more detailed view down here. Like for example, we can see the total audio CPU is there, DSP CPU versus streaming CPU, other CPU, etc. So if you want sort of a deeper dive, you can take a look, and those numbers will update, right? So this is really the kind of detailed data per frame that's being visualized by these graphs. So we're going to talk first about CPU usage. All right, so let's take a look at what we have in the CPU usage category. And this is something I tend to be spending a lot of time in my own projects. That may just be the nature of my project, but I tend to focus on this quite a lot, I guess because I'm often CPU limited. But so what we can see is we can see the scripts, physics, garbage collector, GI, vsync, others, and rendering, right? Right now, rendering is taking up a lot. If we turn it off, we can see really very little happening in terms of other stuff. Right here, we've got a peak. So if we want to analyze, so we've got, there's a couple different interesting peaks here to look at. Right here, we've got a peak in the scripts. So this, scripts are an area that we tend to have a little bit more control over in terms of optimization, because these are our mono behaviors that we've written, right? And theoretically, we might be able to go in and optimize them and make them work in a more efficient way. So in this case, we can see there's a little bit of a bump in the scripts line in the graph. And so what we can do is put our cursor here over that frame and then take a look down here at the overview, right? So the overview is showing us all of the different CPU operations that are happening in that frame. And we can organize these alphabetically by the total amount of time they're consuming per frame, or by the amount of time that function itself or that process itself is consuming. So what the difference is here, if we go to total, so camera.render, for example, is showing a total of 36.3%, but the self is only 0.4%. So what's happening is camera.render is then calling a bunch of other processes, like mainly here in drawing, render.opaque geometry, render.transparent geometry, right, are the majority, a little bit for image effects, but really they're causing these other functions to be called, which is then adding up. So even though camera.render itself is not doing much, calling it is causing all this other stuff to happen, which is consuming, a significant amount of performance. So, or taking a significant amount of time per frame. We can see the number of times it's called per frame. In this case, it's only called once. If we scroll down, we can see, for example, For example, animator.update is being called 6 times, right? And so this means we probably have 6 different animations that are playing during this frame and they need to be updated, right? Or 6 different animators that are doing things. So the number of calls per frame. So if you had, let's say, 100 enemies, each with an update function running, doing something, you might see 100 calls to that update function in the calls column. Now, the garbage collector allocations, this is how much memory is being allocated per frame, right? So this refers to, and please forgive me if I don't do a great job of this because this is still something I'm a little shaky on, but basically we have managed memory, which is the memory that we can access, we can allocate using monodevelop, right? And what happens when we use a piece of memory, it has its value set, and then once we're no longer using it, it's just left there. It doesn't get cleared until we actually need to use it again. So what happens is this garbage builds up, and then we need to trigger garbage collection, which means that all of that unused memory is freed up again. And so our goal in terms of this column is that we want to have a minimal amount of garbage allocated, especially for things like update, which are running per frame, because when the garbage collector is triggered, it can cause especially if it has to clear a lot of memory, it can cause a pretty significant delay. So, you could have a frame that might take, a long time to render, which will look like lag or a kind of a hitch or a glitch in your game. But basically the goal in terms of the garbage collector is to allocate as little as possible. And there are some games made in Unity that don't allocate at all and therefore never trigger garbage collection. And there are ways that you can do that. Then we have the time in milliseconds, and this is similar to the total field, right? So this is showing us, so in this case, the camera.render is taking 4.74 milliseconds per frame to do everything that it needs to do, whereas including calling all the stuff that it needs to call, whereas the self value for that is only 0.05 milliseconds, right? Very, very fast. So these are basically high numbers here are bad, right? You want to try to minimize these numbers as much as possible. Our goal, generally speaking, if we turn rendering back on, now it's kind of unscaled the graph a little bit, but basically we want to be, let me just play again for a second so we can get some more profiling data and it'll adjust. What's it not playing? Oh, I stopped it. Whoops. It'll scale itself in. So it tries to scale the visual display to fit the graph. Look, there's one big spike. So basically here, ideally we want to stay in this kind of, here we're running between 30 and 60 milliseconds. When I was running without streaming, I was going a little faster than that, probably between 60 and 50. But I think streaming is slowing down my computer a little bit. But basically, this, I would say, on standalone desktop computer platforms or consoles, your target should be this 16 milliseconds a frame. And you can budget accordingly. If your game is graphically simple but AI heavy, let's say, you might allocate a bunch of time to the scripts, or maybe it's graphically heavy, like this project. But I would say that is your kind of general performance budget to work within. On mobile, I think a target of 30 is probably a little more realistic. I'm sure people do get mobile titles running at 60, but depends on your content, right? And that's going to be true of any of these things. So we've seen kind of what the different categories are here. And this frame that I just randomly stopped on has an interesting piece of data in it, right? Which is this up here at the top, graphics.waitForPresent, right? Which is a whopping 68.6% of our total CPU, right? What's happening here, what this means is that we are currently not CPU bound, right? So one thing that you're going to need to be figuring out as you profile and seek to optimize your games is what is the thing that you're using the most of, right? Are you using, is the GPU, the graphics processing unit, is that the bottleneck? Is the CPU the bottleneck? Are you running into memory problems? Is it physics or audio or graphics? What are causing the issues? So in this case, if you're seeing graphics.wait for present, what that means is that we're currently GPU bound. So if we weren't rendering graphics, we could run much, much faster, right? But it doesn't make sense to loop through our other scripts until we're actually ready to render the frame. So the rest of the processes are just waiting for the GPU to render the frame before continuing. So it's not a bad thing. I've seen many forum threads where people are saying, why is this is killing my performance. There's another version of it too. I forget what it is. Let's see if I can find it. There's another name for it. There's another one of these that pops up. But anyway, people are like, oh my gosh, 72% of my frame rate is going to wait for present. And all that means is that your GPU is currently working hard. Now, for some reason, you can profile the GPU, but for some reason on my current graphics card driver, it's not working. I know I have a good and working driver, but anyway, but you can profile the GPU as well. I'm just not able to right now. So that may be something you want to look into yourself. So yeah, so then once we kind of narrow in, we can expand these areas, right, and take a look at, for example, drawing, render opaque geometry, render transparent geometry. We can dive down, right? We can look through all of these categories. Now, we could say, for example, like here, we've got 300 calls to reflectionprobes.getSample, right? So we can tell, this is I would say, an acceptable, to use 1% of the total CPU to do that is perfectly acceptable. But let's say you had 3,000 of these, you might realize, oh, I've messed up the way I've positioned my reflection probes, for example, right? So you can keep drilling down until you kind of get to something that looks like something that you could potentially optimize. The area where I find this gets really useful is down here in behavior update, right? Because here we can see all of the mono behaviors that are, and their update loops, and how much those are costing us in terms of time. Now, this is a quite simple project, and so it's not there's no sort of red flags in here, right? And I was considering like making a super broken project and showing you a bunch of broken stuff and then fixing it, but it's actually harder to do than you think. I mean, it's not hard to break your own projects and do terrible stuff, right? But somehow coming up with like pre-broken stuff turned out to be really hard. So anyway, so yeah, we could see, for example, flicker light. So event system.update is going to be the event system that comes with the UI canvas, right? This is a pre-built component of Unity, right? Not something custom. But for example, flicker lights.update, it looks like a custom script that was written for this project, and we can go in and take a look. Okay, it's being called, 13 times this frame. I mean, 0.1% of performance is totally fine for that. But, we might be able to find something to optimize there. So I've gotten a lot of mileage in my own projects out of going through these and looking at, what are these scripts doing, and are they doing anything that's potentially expensive, and can I optimize those? So let's just take a look at, let's see how people are doing in the chat. Okay, that's a good question. I Am Not Shouting is asking, how will optimizations benefit us in our games? I know it's a good thing, but in what ways? So there's a couple of people replying in the chat saying you want your game to run as fast as possible. I'll give a little more detail on that. So it depends a lot on the type of game that you're making, right? But if you're making any kind of game where there's real-time direct control, right? Let's say a platforming game where you want to move the character with the controller and press jump and have them jump. If your game goes below 30 frames per second, it starts to feel really bad. You probably have experienced this Let's say if you're running a commercial game on hardware that's the bare minimum of what it's supposed to run on, or even some commercial games that are just buggy and not well optimized, right? You'll see that, let's say you get into a complicated fight in the game and there's a lot of stuff going on, and the game it turns into a slideshow, right? It starts rendering the frames really slowly. And this feels really bad. It feels like a loss of control. You don't feel like you're controlling the character anymore. It's just a really unpleasant feeling. And so the goal is to have a consistent frame rate of at least 30 frames per second, right? Nowadays, the sort of commercial guideline that a lot of people seem to agree on and want is to be running at 60 frames per second on console and desktop, right? I think 30 is okay on mobile, but I guess it depends on the type of game. But it feels really bad when you have big changes in frame rate. Like, let's say you come around a corner into a complex scene and suddenly the frame rate drops. It feels like the game is like going into slow motion. It just really kind of sucks. So our goal is to achieve consistent performance at a target frame rate. And you might say, the way my game is designed, and the other thing is to achieve consistent performance on your minimum target hardware, right? So you need to decide, I want gamers with a 10-year-old PC with a potato graphics card or no graphics card to be able to run this game. Let's say it's a casual game, or it's a game aimed at gamers who are not hardcore gamers buying the latest graphics cards or hardware. You might have to make a decision and say, I really need this to be able to run on a potato. You're going to need to optimize much more heavily. And very importantly, you're going to need to test on your target hardware, or something that is as close to your target hardware as possible, right? Most of us are very passionate about games and tend to have fast gaming hardware that we're developing on and playing games on. And so that's not a good thing to test on, right? Unless you're going to say, my computer specs are the minimum specs that anybody must have. You need to profile on some less performant hardware. And that's especially true for mobile, and especially if you're targeting Android, where there's just like a huge variety of configurations and different different hardware out there. So something to think about. I know that's one reason that a lot of people struggle to develop for Android, because you just have like a million different screen sizes and different hardware configurations, and it can be hard to deliver a consistent experience. So hopefully hopefully that helps. Let's see what else we have here. Okay, so, all right, I'm just reading. Just give me a second. So Zarbro is asking, are there any general rules for how much garbage collection allocation is bad for performance on mobile? I do not want to put out general rules out there. All I'll say is you just need to profile it yourself on your target device. And I'll talk about on-device profiling in a minute. You need to figure out how often the garbage collector is going to be triggered, and if that's going to be a problem for your gameplay. If it's like a board game, and having like an occasional hitch that you can say, okay, it's we're about to change turns and we have a title card up, we could clear the garbage collector. That's the other thing is, you can trigger when the garbage collector happens. So you could say, I'm showing a title screen, I'm between screens, or it's between turns, or there's a pause. You could trigger garbage collection and have that delay happen in a moment when it's okay. So that's something that you can look into. I'm Not Shouting asks, is it possible to determine the minimum specs from the profile window from your own computer? No. You really need to profile on the target hardware. But what you can, so I guess since we've kind of made our way to this topic, let's talk about it, right? So really important. So there's two ways that you can profile. One is you can profile in the editor, right? Which is what we're doing right now. The scene is running in the editor, and we're recording profile data about that performance, right? But keep in mind, we also are running the editor at the same time. And so it's not going to be as well. Let's say the performance is going to be different than if we're running a standalone build of our game, either on another computer, on this computer, or on, let's say, our target device, whatever that is. So what you can do is you can, when you make a build of your game, I'll just close the profiler for a minute. When you make a build of your game, we're going to go to File, Build Settings. And what you want to do here, I'm targeting Windows, right? What you want to do is you want to make sure that development build is on, right? And what a development build is, it allows profiling. It also allows a console to show errors when you're running like full screen of your build. And then you also want to have Auto Connect Profiler checked, right? And you can only check that if development build is checked. So I'm not going to build this whole project because it'll take a few minutes, but I do just so happen to have a copy of it over here on my other monitor. Let me just grab it. So this is a build of this project, right? And it is a development build with Auto Connect Profiler checked. Let's close the build settings and open the profiler so we can see it again. And where is it? Here we go. And I'm going to run it windowed so we can see the profiler on the same screen. Normally, I would probably run full screen and put the profiler on my other monitor. But anyway, this is fine. Hit play. Move it down here. And as you can see, it has started collecting profiling data from the build. And this really is the type of data that you want to rely on, right? This is going to be much more reliable data than profiling in the editor. And ideally, it's on your target hardware. Now, I'm not going to go into all the different ways that you can profile on device, but basically for mobile, it's more or less the same. You're just going to set your target to whatever your mobile device is, check development build and Auto Connect Profiler. And then I know that for iOS, you need to make sure that the device that you're profiling on is on the local network that your computer is on and wired to and connected with a cable to the computer. And then it should work in basically the same way, that it should automatically connect and start sending should automatically connect and send profiling data. You can also profile over a network, right? You can have, let's say, another desktop computer, run the profile on this computer and have it send profiling data over the network. You can Google it. It's out. The information is out there. That's probably the best case, most accurate scenario, right? Because then we're not running the Unity editor in the background. But, so those are kind of some like ways to approach profiling and general best practices. Now, what I will say is, happily, this is not rocket science and nobody's going to die if we get this wrong. And so what I find is that even as I'm working in the editor, I can see, even if I'm not getting, let's say, a perfectly accurate number about frame rate, I can see proportionally what is going on, right? So I can see if one of my scripts is doing something crazy and taking 10 milliseconds a frame or getting called 1,000 times a frame or something in the profiler, and then I know I need to go and optimize, So I don't I'm not that worried about the specific numbers of everything on the hardware. I'm more worried about the proportion of what each thing is taking up. So let's, if I have a graphically simple game that's very script heavy, I want to make sure that those scripts are well optimized, right? The graphics I probably am not going to worry that much about because I'm probably not GPU bound or rendering bound, right? So just some kind of ways to think about that. All right, yes. Okay, so let's just talk a little bit about these other categories. So we talked about CPU usage. So we have scripts, physics, garbage collector, GI, vsync, and rendering, right? And keeping in mind that some portion of the rendering is taking place on the CPU and some portion is taking place on the GPU, right? The CPU is basically sending meshes or whatever content to the GPU for rendering, right? So the CPU has its part in the rendering cycle, and then the GPU has its part. In terms of rendering, we have the number of batches, right? Batching is a good thing. Batching means that you ideally, let's say, and this is something to think about as you design your scene, if you have multiple objects of a uniform scale using the same material, they can all get batched into a single draw call. So you can optimize the number of draw calls that you're getting that way. So some people will do atlases, texture atlases, right, where they combine all their materials into one texture. It's more than I can get into here, but that's something you can look up if you're draw call bound. And then we have the number of triangles and vertices, right? So this is how the number of polygons in your 3D models. In memory, we have total allocations. Let's see if we can get those. Well, let's actually, so here, this is a useful part of the memory graph to look at, which is the total GC allocated, right? So you can see here, and actually I'll do a demonstration in a second that shows this better, but you can see here, right, it's allocating a little bit every frame, and then right here, we get a spike, it's collecting the garbage, right? The garbage collector is triggered, and then it goes back down and it goes up again, right? So this is something to keep an eye on. Basically, the more frequently this is happening, the worse it is, right? You want this to happen as not often as possible, as infrequently as possible. And that's one way to visualize it. Audio, the number of sources, the number of voices, the amount of CPU being used, and the amount of memory being used. Generally speaking, audio is much less resource intensive than video, than rendering the graphics. So this is probably unless you're doing like a really audio heavy game, this is probably a later stage to look for optimizations, but you can definitely look there. Happily, in Unity 5, the new physics update massively improves the performance of the physics simulation, in my experience. I have a personal project where I'm using lots and lots and lots of rigid bodies moving around and colliding, and just by upgrading to Unity 5, I got a huge bump in performance. So if you're holding out on upgrading and you're doing a game that leans heavily on physics, especially like lots of physics calculations, you just do it. You will be happy. And it's also solved, I'm not going to say solved, but it's minimized some of the really bad things that we would get with the old version, where if you moved, let's say you animate a cube without putting a rigid body on it and move it, you're moving what the physics system thinks of as a static collider, you get terrible hits to performance. And that is now somewhat improved. You still shouldn't do it, but you're not going to get just killed like you used to. And so here we just have the number of rigid bodies that are active, right, as opposed to the number that are sleeping, right? So once a rigid body comes to rest, stops moving, it will go into sleep mode, which means it's not taking up very much resources at all. And you can manage that manually if you want. You can call rigidbody.sleep. And then the number of contacts, right, is just how many physics contacts are happening in this frame. These are really low numbers. You can go much, much higher than this without getting like really bad performance. And that will add up in the CPU category, right? So this just gives us a view of it separately, but this rendering, physics, this is kind of why I focus a lot on this, is because these are all going into the CPU category, kind of like the difference between self and total in the CPU category itself. So let me show you now I'll just do like a little quick example of, quick, sort of very fake example of how we might use this, right? So I'll dock the profiler. Let's create a new game object, which we'll call logger. We're going to add a component. So I just did game object, create empty, double clicked it to call it logger. And then on that object, I'm going to add a component, a new script called logging stuff. And since it doesn't exist, you double click, then you can create an add. Started using this a lot. Actually, it's a pretty quick way to add things. And then you don't make the script and forget to put it on the object. It's just added right on. It's a nice little workflow thing. And double click it to open it in MonoDevelop. Let's maximize and zoom in. 2, 3. Okay. So what I'm going to do is I'm going to do something not performant, right? I'm going to put in update, I'm going to put a debug.log statement saying the time is time.time, right? So this is going to show us the time from when the project started in seconds, and it's going to log it every frame. Now, it turns out, this is something I didn't know when I first started working with Unity, this is really expensive performance-wise. So if you have a game with a bunch of debug log statements, especially running often or a lot of them being called, turn them off and watch your performance take off like a rocket. I was so surprised when I found out how expensive this was. I don't know why that's the case, but anyway, something to be aware of. So I'm going to save the script, and let's jump back to the editor. And actually, I want to open the profiler as well. And actually, we can just keep it open like this. So I'm just going to play. And we will see. Let's see if we can. I'll just close it for a sec. We'll see in the console, right? We have the time getting logged every frame, 177 of those. And I lost my data. Way to go, me. Okay, let's do that again. I know what I'm doing, I swear. Okay, and then let's look at the CPU usage, and let's drill in behavior update, logging stuff dot update, log string to console, taking 2.5% of our total performance budget, allocating 3.7 kilobytes, not bytes, kilobytes per frame, right? So this is going to trigger the garbage collector all the time. And C, let's see if we've gotten enough time to trigger it. Yeah, I think that's a spike from it. Let's play a little bit more. We'll definitely see it. Just hitting Control P to play in the background. Let it run for a second. We can see that those garbage collection spikes happening. And then we should see somewhere in here a nice big spike. There it is. So this 6.5 millisecond spike for the garbage collector, right? And that's just going to keep happening again and again. Not good, right? So this is an example of the, let's turn off rendering because that makes it look crazy. This is an example of the kind of thing that we could diagnose, right? We can see, first of all, this thing is just really not performant. It's taking 5% of our overall performance budget, allocating like crazy. 7 milliseconds is just horrible. And we can find that stuff using the profiler, right? This is the kind of stuff. I remember when I first got, I had this project I've been working on forever, struggling this was in Unity 4.5, I think, or 4.6, struggling to get it to move to get to 30 frames a second, I think, without the profiler. And then I got access to the profiler and just suddenly was able to clear out all this terrible stuff I had done with scripts that I'd forgotten about. I'd written them a long time ago, and then when I knew much less, and they're running every frame doing terrible stuff. So it's nice. It's a nice tool. So Senor Mall says, I'd never thought that debug log would be so expensive. I didn't think so either, but that's what the profiler is good for, right? The things you think would be cheap may not be, right? So you want to get some data, not just guess at what you think is going to be performant. There was a question earlier about deep profiling. So what deep profiling does, actually, let me not turn it on. Let's get this lined up differently first. First of all, I think we've proven our point with that guy, right? Let's turn him off, delete him. What deep profiling does is it heavily instruments basically all of your function calls. So it adds a whole bunch of profiling overhead. So if you have a game that is right up against your performance budget on your development machine, you may not be able to do this. Your game may get so slow in doing this that you can't use it. And I'll show you another workflow that's a little more precise that you should be able to use. But this is kind of like if you're just trying to figure out like what is going wrong among a bunch of different things, this may be useful. So I'm going to turn deep profiling on, play, collect some data. Rendering's not off. That's okay. And then what we'll see as we go through, let's look at behavior update. We can see, for example, let's look at flicker lights, right? We can hold on. Let me actually turn my silly script back on here, so because we looked at that a second ago, we can compare. Game view looks crazy, squished like that. Okay, so now what we can see in behavior update is that in logging stuff.update, we can see the debug.log statement, the string operation here. We can see time.getTime. So we're seeing now each of the separate functions that's getting called with more detail in the profiler, right? So this can be a good option if you're really trying to get to the bottom of something and you don't have any idea where it is. Now, if you have some idea where it is, and this is kind of like a good idea as you're writing your game code, let's turn this off. I'll go back to my silly script here. And what we can do is we can actually add profiling to our scripts ourselves. So I'm going to say profiler dot begin sample, which takes a string. We'll call this log test. And then let's just, we'll say do stuff. There's other stuff happening here. We'll pretend. And then we will profiler.end sample. And so, excuse me. And so what we can see is now we can profile this piece of code and it'll appear under the name log test. Oh, I didn't save. Save. Let it compile. And test. And now, if we go into behavior update, logging stuff.update. Oh, no, wait. Oh, this is my old data. Here it is, yeah. Okay, that was just the old data from last time I played with the deep profiling on. Here's the new data. So we can see log test appears as its own process, and then we can see there's log string to console, right? So this is a way that you can go through and add tests just to specific pieces of code. And I would say this is probably a good idea to do as you're designing your core loops and core scripts of your game. Just make sure that you're not building functionality around, I don't know if you want to do it as you're building it, but you just try to be aware of what the stuff you're adding is doing to your frame rate, and maybe, if you see something weird, just check on it to make sure that you're not building in some crazy performance consuming monster, which is easy to do when you're having fun developing a game. GM Liquid Media asks, is there a way to do something like fixed update, but only every 10 frames? I have a function that only needs to update a few times each second. Yes, there is. That's a great question. There's a couple ways you can do this. This is something I just ran into recently and that I had found a fun solution to, which is that you can make your own looping coroutines that you can set the rate for. So you don't have to use update, right? You could use, as somebody points out, you can use invoke repeating. That works. But you could also use a coroutine, which maybe, let's see how time, we're almost out of time, but let me see if I can, maybe I'll show you guys in a second. Camille Che, yes. If you had a single debug log per frame, it would be bad, yes. I mean, ideally with debug.log, you turn it on, do your logging while you're trying to figure out what's broken usually, and then just comment it out. You can leave the code in there, just comment it out so it's not running. Okay, the other questions were, can we see the frame debugger? Yes, we can. We can just see it quickly. The frame debugger allows you to debug what's happening as each frame is rendered. Open the frame debugger, hit enable, play, pause, no. There we go. Okay. Doc, can I do it? Yes, seems like that worked. Okay, so basically what this does is it's showing us a list of all the rendering events that go into drawing this frame, right? So, and it gives us a little scrub so we can scrub through them, right? So we start, this is the empty frame. We're going to draw this mesh first, draw these other meshes, draw these guys, apply the decals, and scrub through as everything is rendered, everything is drawn, right? Then here we're drawing the, we're rendering the shadow map. And again, here we're applying the image effects, the, what is this? Depth shadows. And you can get information about each process here, right? Here it's showing us the mesh, and it should actually highlight it somewhere. Maybe if we highlight it anyway, it'll highlight it in the hierarchy. More shadows. Image effect, what's this doing? Spot shadows. So basically you can see as each thing is applied and troubleshoot, like here it's applying, that was the, where's it, the normals? I can't even get on it. Here we go. Where was it? Here we go. Now it's drawing the normals. And so you can look at each step and troubleshoot it. I must confess, this is a little bit, I'm just not that deep into the graphics pipeline. This looks like the SSAO. Yeah, that's a pass for the pass 1, pass 2, pass 3. It's kind of interesting if you want to see how the rendering pipeline works, right? Here it is applying the bloom, right? And blurring it and then mixing it in. Drawing more stuff. You can move down by pressing the arrow key. Drawing, drawing, drawing. And I think that's the tone mapping. So basically you can walk through, and then if you want, you can, if we go to something like the, this is rendering, I think the albedo, right? You can check out the different render targets. So this is the albedo. We can look at the specular, normals. What is this? I forget what this is. The depth buffer. We can also visualize just the red channel, green channel, blue channel, alpha channel, and dial in just a specific luminance range using the levels slider here. So if we're just trying to, like, which can be useful for HDR stuff. We're trying to look at a certain range. This is probably not something you're going to need to use all the time, but if you run into some kind of hairy graphics problems or shader problems, this might be your friend. What was the other thing I wanted to show? Oh yeah, the other thing I want to show real quick in the profiler is that you can, oh, I probably need to close the frame debugger. Close, play, Control 7, let's get some data. Stop, okay. Is that you can visualize a frame in a timeline view. So we can see here, here's the render thread starting, and then we're waiting. So this is the whole frame. So basically we're waiting to get stuff from the GPU for about half the frame, then doing stuff, and then taking that stuff and drawing it. I confess I am not that familiar with this. This was added in 5 and is new, but you can see, for example, here you can see that this is the main thread, this is the render thread, and then we have other parallel threads, right? So these are all running in parallel, so working at the same time. So like the mesh skinning down here is happening in parallel. And I know I actually, in the process of researching this session, I was reading some posts that Arash, who's one of our graphics programmers, was writing about optimizing the render thread to make it more parallel like these other threads, because right now you see it's just one big thread. So I know that's in progress, and they're, I think, getting some good optimization out of that. So, you know, it's always being worked on. But this may be a useful way to visualize your data as well. So let's take a look at the chat. So that's basically our show for today. I will hang around and answer a couple more questions. I'll do my best. Some of this stuff is a little bit new to me as well, so don't try to stump me too hard. And for the new people, welcome. Hopefully you had a good time. And to the regulars, great to see you again.